Hello friends, this is Yashwant Savai. Welcome to BWE Best Ways Essbase, learning solutions for Hyperion, Essbase and planning developers. Friends, today we are gonna learn about the outline design best practices. So, in this regard, we have focused on the three sections like one database per application, dimension positioning and naming convention and other. So these are the three sections which are useful by which we can design our outline in a very good manner. So before directly talking on the outline design, let's talk on the application level. So what the Oracle recommend is for an application, we should have the one database per application. So one database per application is going to be beneficial under these 5 points listed here. So before talking directly on how the dimensions and the members will be ordered in our outline design, we will first see how many database we should have in an application, and how the multiple databases and the one database is going to affect the overall performance of the application and the outline as well. So the points we are going to discuss here are memory utilization, concurrent dimension builds, single point of failure, single lock for application, and the user provisioning. We'll elaborate it in a brief manner. So if we talk about in terms of the memory utilization, so the application in an Essbase or planning runs under an SVR process. So there is an SVR process per application in the Essbase. So if my application is having single database, then that single database will consume the SVR process caches that are being used by that SVR process. So all databases within an application run under the application's SVR process. So suppose if my application is having more than one databases, suppose database 1, database 2 and databases 3. So the SVR process in memory has some memory addressability. So this addressability should be rationed by these three databases, which causes the engagement of the caches being used by the SVR process. That's why the caches may be engaged, and the same caches are used for the SVR process of the application, which can cause the performance or which can cause the slowdown in the performance for your application, and which can slow down the response time of the application if we are having the multiple databases in the single application. The next is concurrent dimension build. So dimension building may require the database restructures, and when the database is restructured, the copy of the database is restructured, the copy of in this case the two copies of the outline, suppose if my application is having more than one database, then the two copies of the outline reside in the memory, which is the random access memory, my primary memory RAM. So thereby engaging the RAM may cause the slowdown in the performance for the application. The next is single point of failure. So if suppose my application is having three different databases for suppose one is for sales forecast, second is for workforce planning, and third is for suppose capex module. and by some reason one of the database is I'm unable to start the application by some reason or any technical reason. So then in that case all the three modules are inaccessible, whether in the case with the one database per applications. So if my application is not able to be started, then my remaining modules residing in the another applications are safe and secure in that time, and I can if my all the all the databases are in single applications, then we'll have to wait for to access the other modules until the issue is resolved. So it is good to have it is good to have and recommended by the Oracle that we keep one database per application. The next is single log for application. We know that Essbase writes information, warning and other error messages for databases into the application log. So each application has its own log. So suppose if my application is having the multiple databases, so my application log will contain the information, warning and error messages matched up for all the three databases or whatever the number of databases I am having there in the application. So ultimately the log that is being generated will be a matched log for all the three databases, which will not be easily readable, and to trace an error in that matched log is not easy. One database per application also provides us the flexibility in the user provisioning at the database level. So if I am having the one databases per application, so I can have the various different access to the users on the different modules. While in case if all the modules are in a single applications, then whatever the access I am providing to the application will be granted to all the databases. So I cannot differentiate the user access on the database level. So I'm not talking here about the standalone security that is the allotted during designing the user provisioning. Currency conversion applications are the exceptions for this one database per application rules, as the currency conversion applications have an additional database, additional exchange rate database that it used for converting the local values into the main currency values. So I'm not talking about here the currency conversion application. So these applications will be the exception for this rule. So we have seen all these points for one database per application rule, memory utilizations and all, how the exception for the currency conversion application is not applicable here in this case. So the next is, let me find out the next slide. So yes, the next is optimization through positioning of dimension and storage properties of dimensions. So this section will now we will going to focus on the order of the members in the dimensions, and what the storage properties we are going to assign to the members of the outline. So here we will deal with the main concern for which we are here, for which you are here in this presentation.
Yeah.
Optimization through outline designing is done by positioning the members and the dimensions of the outline and storage properties of the dimensions. So in this regard, suppose if my outline is having the attribute dimensions, so we will have to place the attribute dimensions at the end of the outline. This is recommended. And if my outline is having the dense dimensions, so we will position the dense dimensions before the sparse dimensions. So the structure of my outline should be like the structure of the outline should be here listed: dimension 1, dimension 2, dimension 3, dimension 4 and 5. So as we can see here, the attribute dimensions are at the last of the outline. Then above the attribute dimensions we have the sparse dimensions, sparse 1 and sparse 2, and at the uppermost we can see the dense dimensions. So our outline structure should be in this way, like my dense dimensions would come first, then the sparse dimension and the attribute dimensions at the last. So friends, this dimension positioning and dimension storage properties affects these two areas of performance. So if I am very much worried about the calculation speed, how quickly calculations are run on the Essbase, if I am worried about that, so these dimension positioning and storage properties would be different for the calculation speed. And if I am worried for the retrieval speed, how long it takes the user queries to how long Essbase takes to respond to the user queries, then the dimensional positioning and dimensional storage properties would be different for that configuration. So we will see for both for calculation speed and as well as the retrieval speed, and then combined and the case for the combined requirement for calculation speed and retrieval speed both. So if we talk about the retrieval speed, the first rule, if we are designing for the retrieval speed, is we will place the more queried sparse dimension before the less queried sparse dimensions. So here is a outline structure taken from the Oracle's documentation, Essbase documentation. So let me explain you this in short. This is the outline. Here it is the measures, dimensions, year and scenario. These three are the dense dimensions, and let me make it a full. And product, market, suppliers are the sparse dimensions, and ounces and package type, these are the attribute as well as the sparse dimensions. So we said that the more queried sparse dimensions will be placed before the less queried sparse dimensions. So friends, here we can see if the product is the first sparse dimension and the market is the second and the suppliers is third. So in this design the product is at the first place. As we can see here, the ounces package type, these attributes are assigned to this product dimension. So let's take an example, user would always be interested, as far as this design is concerned. We can expect that user is much more interested in analysis based on the package type and ounces. So the whatever the data user will retrieve will be mostly based on the package type and the ounces. His analysis trend will be strongly based on the package type and ounces mostly. So in this case, this design suits fine. So if it would have been the situation like if I want the data to be retrieved by the market positions, so if I would have an attribute based on the large market, small market, or middle market. So if most often if I want to see what the sales, how much sales my middle market is expecting next year, or if I want to see the actuals based on the size of the market. So in that case I would have been placed the market at the first and the product at the second. So this depends on the user requirements and what kind of the data analysis the user is going to perform. So this totally depends on the user requirements. So in this outline design, as we can see, the user is interested in seeing and analyzing the data based on the package type and ounces. So they have put the product as a first sparse dimension. In case in designing for the calculation speed, the ordering is done based on the numbers of members sparse based on the number of members sparse dimension is having. So we will order the smallest sparse dimension first, means the dimension having the smallest number of members would be kept at number 1, and then the another sparse dimension having more members than the previous one, and so on. So we will sort it in ascending order of numbers of members. So if we see here the same sparse dimensions which we have seen in the previous example for designing for retrieval speed. So we can see here the market followed by suppliers and then product. So the market will be having suppose 10 members, then suppliers is 20, and product is 25. So when we want to focus on the to improve the calculation speed of our calculations and the business rules or calculation scripts, so the dimensional ordering will be done in this way, and as we can see the order of the sparse dimensions matters more because as compared to the dense dimensions, because the one rule is we have to first set the dense dimensions at the uppermost number, the uppermost level. Then the dense dimensions are followed by the sparse dimensions. So the below the dense dimensions we would have the sparse dimensions, but the approaches we are following for calculation and retrieval speed just differ in the ordering of the sparse dimensions, because the Essbase stores data on the combination of the Essbase stores data for the combinations of the various members on the sparse dimension members, and it creates blocks for the various members from the sparse dimension members. So the ordering of the sparse dimensions matters more. So these were the two cases if we were designing for the retrieval speed and the calculation speed. If we want to achieve both, that my outline is designed in such a way that it is optimized for calculation as well as for the retrieval, then we here are some points written for meeting the needs of both calculation and retrieval. In this, we need to prioritize the data retrieval requirements of the user against the time needed to run calculations on the databases. So what is the more important? We will prioritize that does user gives more importance to the retrieval speed or to the calculation speed. We will prioritize that, and based on that we will conclude and how often do we expect to update and recalculate the database, and what is the nature of the user queries, like if the user is if the user most often queries the database based on the attributes like we have seen for the retrieval speed for the package type, and what is the expected volume of user queries, how much data normal user can retrieve. So what the possible workaround is, initially we can position our dimensions in the outline for optimizing the calculation. So what we will do is that we will first focus on optimizing the calculations, and once we are done with the calculations, we can reposition, we can manually resequence our dimensions for optimizing the retrieval, and we can achieve this. We should do this by restructuring our database by index only. So since indexes are generated for the sparse dimensions, so this is the way how we can resequence the dimensions to optimize the retrieval, and later, before running the calculations again, we can again resequence the dimensions in the outline to optimize the calculations. So in this way we can meet the needs of both the calculations and the retrieval, and this is quite typical and quite much engaged process that needs to work around, but this is mostly possible in the cases when your calculations are being performed on the monthly basis on your database, and not frequent calculations, and your incremental data load is there, and you are performing calculations on that data on a monthly basis. So you should not have to frequently resequence and reorder your dimensions and members, the dimensions. Naming conventions, here are some recommendations and limitations for the naming conventions, for the naming the members and other application artifacts in the Essbase. So first is member, dimension and aliases names are limited to the 80 characters. We cannot use more than the 80 characters for member names, dimension names and aliases. If we try to do so, definitely the outline is not going to verify. The second is application database, and application and database names are limited to 8 characters. So maximum of 8 characters we can provide in the application and database names. And the third is duplicate member names. It is recommended that not to use the duplicate member names because duplicate member names may require specifying the nodes with the member names while using in the calculation scripts or business rules. So wherever we will be referring the duplicate member names, we will have to specify the nodes for the duplicate members names. We can cause the time consumption during at the runtime while resolving the names at the runtime. Next is case sensitivity. So the by default the case sensitivity is not enabled in Essbase, so which is great while using the smart view on the ad hoc basis or ad hoc mode. So it is quite handy for the user to work on the smart view, so we do not need to worry about the entering the letters in a capital or small. And the next is not to use double quotations or tabs anywhere in the member names or any other artifacts names. This is recommended by the Oracle Essbase. And we should strongly avoid the special characters in the member names and application or database name, spaces at the beginning or end. So if we do not want to if we do not want to get stuck with our code and the members being used in that, this can, if we are having spaces at the beginning or end of the member names, so it may cause the time consuming hidden traps, and we will start staring our code that why it is not working as we are expecting. So it is strongly recommended not to use spaces at the beginning or end of any database artifact member or a dimension name. So and next is we should avoid using formula names as member names or alias names. So these were all naming convention recommendations and limitations what the Oracle recommends. So that's it for outline designing best practices. Thank you. For any queries you can email me on yashwantsawai615@gmail.com, and please do not forget to subscribe this channel based with Essbase. Thank you.